we're asked to describe the end behavior of these functions. The first function is f of x equals negative 3x to the 8th minus 4x cubed plus 2. Note that the degree of the function is 8, and that is even. So therefore, the left-hand behavior and the right-hand behavior are going to be the same. Since our leading coefficient is negative, that means that this graph is going to fall to the left, and it's also going to fall to the right. So a non-technical way to write the answer is the end behavior is down, down. Now, if we want to be a little more descriptive, since we're in pre-calculus with our answer, we could say, as x approaches negative infinity, y is also approaching negative infinity. As x approaches positive infinity, y approaches negative infinity. Or we could give an even better answer and write it the way that we would in a calculus class, and that uses the idea of a limit. The limit as x approaches negative infinity of our function f is equal to negative infinity. The limit as x approaches positive infinity of our function f of x is still negative infinity. So there's three different ways to say the same thing. On the next example, we have f of x equals 4x to the 5th minus 3x squared minus 1.5. So this time, the degree of the function is 5, which is odd. So the ends are not going to do the same thing. Since our degree is 5, and our leading coefficient is positive because it's positive 1, our function is going to fall to the left and rise to the right. So our end behavior is down, up. So if we want to write this a little bit more technical answer, we would say as x approaches negative infinity, our y is approaching negative infinity. As x approaches positive infinity, our y values are approaching positive infinity. Or if we want to write it the calculus way using limit notation, the limit as x approaches negative infinity for this function f is equal to negative infinity. The limit as x approaches positive infinity of this function f is positive infinity.